Multiplicity stuff is a question like example 5 when the binomials have exponents. If they don't have exponents like in 4 or when you factor that there isn't a repeating x-intercept, you're not going to deal with the multiplicity. It's only when you have something like this where there's exponents. If the exponent is odd, what it means is it goes through that point. If the exponent is even, it means it sits on that or it bounces back up. So just grabbing this sheet that we were talking about. This first example is there's no multiplicity, so there isn't going to be any kind of bouncing in this case. This is just a normal parabolic question. How do I know this is a parabola? Because it's going to be x squared when you multiply it out, so the degree is 2. When you solve, x is going to be a and b, meaning they're both positive. So what this means in this case is it's a parabola that goes through both of those points because there is no squared or cubed or higher on the binomials. Okay, it's just a straight up normal kind of polynomial question. The second one has a multiplicity. First thing I need you to do is figure out what kind of quadratic is it, or what kind of polynomial is it. Quadratic, is it cubic, is it quartic, is it quintic? How do we know it's cubic? Yes, and how do I know from this I'm going to have a degree of 3? So this one's going to be squared, this one's going to be to the 1. When you multiply them together, it's going to be a cubic. This would be x minus a, so we're going to have some kind of value on the negative side of the x-axis. This would be x equals positive b, so we're going to have a value somewhere on the positive side. Because there's no multiplicity here, it means it's going to cross through. What does it mean here? Is it going to cross through that point? No, it's going to turn around and go back down. That's what it means when one of the binomials is not squared and one is squared. Third situation is just the reverse. So x equals negative a, there's going to be a point on the left-hand side. X equals b, there's going to be a point on the right-hand side. It's going to come from the bottom, just touch a, and then actually go through b. Why did it go through a in this example, but it didn't go through a in this example? Because a has the multiplicity, so we just switch where the multiplicity is. What if we have double multiplicity? How do we know this is going to be a W? How do we know it's quartic? Yeah, so we're going to have an x squared here. We're going to have an x squared here. When we multiply those together, we'll have an x to the 4. So these are, a is going to be on the negative side, b is going to be on the positive side. So it's going to come from the top. Just touch a, have some kind of max in the middle. Just touch b and bounce back up. Those are basically the different kind of scenarios you're going to run into.
If that was negative, would it just be like
It would be underneath, yep. Do you get the multiplicity thing? Okay, let's do the last example, number 5. Oh, I lost my paper. Here it is. Just putting the steps back in your head, first thing we do is name it. Think about the leading coefficient and the end behavior. Picture the graph, calculate the x-intercepts, and then we do test points where we need to. So again, first thing we do is we don't have to necessarily write it down, but we think about what kind of polynomial is this. Is it quartic, cubic, quintic, quadratic? What's going on here? Quartic. Why is this quartic? Yep, so we're going to have an x squared here, an x squared here. When we multiply them together, we're going to get an x to the 4. So this is quartic. What about the end behavior? Is that x to the 4 going to be positive or going to be negative? It's going to be positive. So now you have to think of an even polynomial. End behavior, what happens when it is positive? So picture a parabola, because it's the one you're used to. What happens when it's parabola? It's up, up. Okay, so we know this is going to have the W shape, and we know it's going to point up. So that's steps 1, 2, and 3. So the first thing we actually do to calculate this is find the intercept. So I always start with the y-intercept because it's easier. How do we do a y-intercept? BEDMAS says we do the brackets first. So 0 minus 1. Minus 1. And 0 plus 3. Then we do the exponents, minus 1 squared, 3 squared. And then lastly, the multiplication, 1 times 9, 9. So that's a 0.09. X-intercepts. Ooh, it's already onto it. Again, they've done the factoring for you, so this just becomes a split and solve. How do we get rid of a squared? What's the opposite of squaring something? Square root. Square root of 0. So x equals 1. Okay, so don't let the squares get to you. It's just a simple square root of 0 on the other side. We could, but then we'd have plus or minus 0, and since Andrew's not here, it doesn't matter. It doesn't exist, right? So square root of 0 is 0. Whether it's plus 0, minus 0, it's all going to be 0. I'm just waiting for the day Justine blows at him. Like, it's coming soon, I think. I think so. Okay, either draw your axes or grab your sticky. How about we put it the right side up? That was so left brain that I had to put it the right side up. Can't help it. So we have 0, 9. One 0, negative 3 0. The first intercept, the negative 3, does it cross or does it sit? How do we know that it just sits on that x-axis? Because the multiplicity is even. So we know it's going to come from the top, and it's just going to hit that guy and bounce back up. It's going to go through negative or positive 9 at some point. It's going to come back down to our 1. What happens at 1? Why does it just sit there again? And there we go. Yeah, we're okay with it. It means that the max is actually right beside, but it'll be close, so we're okay. They're going to give marks as do you have the right y-intercept, do you have the right x-intercepts, do you have the right end behavior, and do you have the right quadratic, or right polynomial. I just want to make a note. I should have said it when we did this sheet here, but I forgot. When it crosses through, if you noticed, and I should have said it when I did it, it doesn't cross through straight. It actually has a little bit of a bend to it because it's kind of like a cubic. So when you draw these, it's not like a parabola that goes straight through. It's got that little bit of snakiness to it. I feel like I should make a note in red. snake shape. Parabolas don't, but cubics and above do. They have kind of that thing. Like the base graph for x cubed has that snaky shape to it.
What about the one next to it when you close it up?
This one, I should have done it too. You were right. Thank you. High five to you.